Have you ever stared at a dense technical manual, maybe hundreds of pages of jargon, and just thought, how am I ever going to pull out the really important stuff from this? That feeling, information overload. That's exactly what we tackle here on the deep dive. Today, you've sent us a particularly interesting stack, excerpts from this comprehensive training handbook, Introduction to ABAP Programming on SAP S/4HANA. Our mission isn't just to, read a manual together. It's about unlocking the key insights from these pages. We want to quickly get you up to speed on a really powerful programming language that, honestly, countless businesses rely on worldwide. Okay, let's dive in.
That's right. ADOP, it's SAP's foundational language, and it's quite a history. And its evolution, especially, with the move to S/4HANA, it reveals some really fascinating, crucial shifts in how big enterprise software gets developed. We'll try to connect those dots for you, show how that history really shapes its role today.
So to really get S/4HANA, we need to rewind a little, don't we? What was it like with the older SAP systems, like R2 and R3? What problem was SAP actually trying to solve?
Well, those older systems, they became incredibly sophisticated, maybe even, overly complex sometimes. They really ended up catering to these highly specialized power users, the ones who knew every single detail. With S/4HANA, SAP's core mission was sweet and simple. From an IT point of view, this meant simplifying the whole system landscape quite dramatically and really cutting down the total cost of ownership, the TCO. And for the business users, the goal was a much more intuitive role-based experience, what we now call the SAP Fiori UX. Less training, more productivity.
It sounds like the SAP HANA database was the real game changer for that simplification. What was it about HANA specifically?
You're spot on there. The SAP HANA in-memory database, that was the true catalyst. Its platform features, especially real-time analytics and just incredibly fast data processing, that changed everything. By putting data right into memory, HANA could process huge amounts of information almost instantly. That foundational shift, well, it allowed SAP to completely redesign applications, leading to the simplicity and speed we see in S/4HANA.
That makes a lot of sense. Now, thinking about this from a programmer's angle, when we use a typical app, it's often like a black box, right? Input goes in, output comes out, but we don't see the inner workings. But programmers sometimes face this white box situation. Full control over everything, UI, database, the lot. Powerful, sure, but probably really inefficient. Lots of repetitive work, I imagine.
Exactly. Things like building similar UIs again and again, or writing basic CRU'd operations, create, read, update, delete. It gets tedious. And that's precisely why the S/4HANA programming model is often described as, somewhere in between. Developers definitely still need to build custom applications, extensions, meet those unique business needs, but they shouldn't get bogged down by those repetitive generic tasks. The solution here is using frameworks and APIs, application programming interfaces. Think of a framework as this smart subsystem handling all that common stuff, generating UI element, managing data flow. And then at key points, it exposes an API. That API is like a controlled gateway, letting developers inject their own custom ABAP code to steer what the framework does.
Ah, okay. So the system handles the generic scaffolding, and developers fill in the custom logic, the unique business bits. That's a huge insight into how these big modern systems work. So where does ABAP itself, the language, fit into this? Is it still as central?
Oh, absolutely. ABAP is still central in S/4HANA, but its role is maybe more specialized, more integrated. For the user interface layer, new apps mostly use SAP UI5, that's JavaScript-based, gives them the modern web feel. But ABAP is definitely still used for older applications, things using conventional screen tech or WebDyn Pro that were brought over from the business suite. Then, down at the database layer, new applications rely on Core Data Services, CDS, for modeling, and the Business Object Processing Framework, BOPF, for handling data changes consistently. But again, lots of existing applications still use a more all ABAP approach for database work. But critically, in the application layer where all the complex calculations, validations, the core business logic lives, AV plays a really strong central role. Frameworks provide hooks for your custom ABS.
And that application layer, the ABAP programming itself, that's exactly what we're focusing on today. We're looking at writing programs using the ABAP development tools for Eclipse ADT running on the application server. The source material mentions that user input-output is mostly handled by routines provided, which is great, actually. It lets you, the listener, really focus on mastering that back-end logic. So we get why we're coding in ABAP in S/4HANA. Now let's talk where. What's the modern ABA developer's toolkit actually look like?
Right. So historically, developers used the SAP UI-based ABAP workbench. That was SAP's own environment, tightly integrated, versioning, where used lists, all that. But as SAP expanded, Into SAP AB API 5, they needed something more versatile, a common ground. And that's where ABAP development tools for Eclipse, ADT, comes in.
Makes sense.
It's popular, open source, really extensible. SAP built ADT to give developers a consistent, modern environment across ABAP, AP, and UI5. It's important to realize, though, while ADT and the old Workbench share functions, they're not identical. Some newer things, like those core data services views we'll talk about, you can only edit them in ADT.
That's a key distinction. So for someone new to ADT, what are the core concepts they need to navigate it? It sounds like a big environment.
Well, Eclipse uses perspectives. Think of them as preset layouts optimized for tasks like ABAP development or debugging. Each perspective contains different views, like the source code editor, an outline of your program, a problems view for errors. Your first step is always creating an ABAP project. That's how you log on to the backend SAP system. You can pick an existing SAP logon entry or enter the details manually, user, password, and, importantly, the logon language, often English for development objects for consistency. ADT has really good Eclipse editors for source code things like the ABAP editor or the class builder. But for older tools, maybe form-based ones, it actually opens the classic SAP GUI interface right inside Eclipse. It's integrated, which is pretty handy.
Okay, that sounds pretty seamless. But what's something that often trips up new users? What might feel a bit chaotic at first?
Yeah, probably the sheer number of open tabs. Every object opens in a new tab, and suddenly you've got dozens open. Hard to find things. Quick tip, Ctrl plus Shift plus W closes all tabs. Lifesaver sometimes. Also, if you mess up your layout, close the view by mistake, just go to Window Master Perspective, Reset Perspective to get it back to default. Finding objects. Usually you navigate via the package in the Project Explorer, Packages Group Related Objects. You should definitely add your common packages to your favorites. If you don't know the package, Ctrl plus H is the general search. Or, if you know part of the name, Ctrl plus Shift plus A for Open Object is super fast. You can even filter that search like type.prog for programs, type.devc for packages, type.table for tables, type class for classes. Really speeds things up.
But what if you need that classic SAP GUI for some admin task, something ADT doesn't cover directly? Are you stuck switching windows?
No, not at all. You can run SAP GUI transactions right in ADT. The shortcut is C to whale plus 6. It just opens an SAP GUI window inside Eclipse using your project's connection. Super convenient. And one tool you'll definitely use there is the Repository Information System, Transaction SE84. It's essential for searching through, well, literally millions of development objects in an S/4HANA system, over 4 million typically. You can search for function modules with wildcards, maybe day, or limit searches by application component like Copier. It really shows you the scale we're dealing with.
Wow, 4 million objects. Yeah, that puts it in perspective. Okay, let's touch briefly on software logistics. How does code actually move around?
Right, the basics. You typically have a multi-system landscape: development, testing, production. You develop in dev, test thoroughly in test, and production is live business data, absolutely no developing there. To move code between these in an orderly way, SAP uses the change and transport system. As a developer, every object you create or change has to belong to a package. The package groups things logically and also determines its transport layer, how it moves. And every change needs a change request. Think of it as a container for your work. These requests have tasks for developers and are used to transport objects from dev to test, then test to prod. And crucially, for any custom development, you must use the customer namespace. Your object names need to start with Z or Y. This stops your code clashing with standard SAP objects during upgrades. It's vital. So the life cycle is create object, assign to package request, finish work, release request. It goes to test. Test approves. Release again, goes to prod. If you change it later, it needs a new change request.
Okay, environment setup, transport understood. What's the very first line of code likely to be? What are the absolute fundamentals in ABAP?
Well, you almost always start with variables. They're basically name slots in memory to hold data. Each one has a size, a type telling you what kind of data it holds, and of course a name. You declare them with the data statement. Good practice is often prefixing global variables with G just to make them easy to spot. ABAP have lots of predefined types. You've got complete types like I for integer, int8 for big integers, DC float for floating points, D for dates, YYYMMDD, T for time, HHMSS, string for text, xstring for binary data, and incomplete types where you give it a life like C for character strings, N for numeric strings, X for byte sequences, and P for packed numbers. Type P, packed numbers, are really important for business logic. Very efficient for calculations, especially finance, storing 2 digits per byte. And here's something really key to SAP's whole approach. Data elements in the ABAP dictionary. This isn't just a technical detail, it's fundamental architecture. The dictionary is central. Data elements define not just the technical type, but semantic meaning too. Things like user-friendly field labels, input help, even validation rules are stored centrally. Take the material number, MATNR. It went from 18 characters to 40 in S4HANA. Imagine changing that everywhere manually. Because it's a central data element, you change it once in the dictionary, and it updates everywhere. That's how you manage huge, complex systems consistently. You also find types defined locally in classes with types.
That central dictionary idea is powerful. Okay, so we declare variables. How do we get data into them and start working with them?
Right. By default, variables have initial values. 0 for numbers, spaces for characters, a single space for strings. You assign values with the mirror sign, or you can use the value addition right when you declare it. Data gvcount type I, value 1. To reset a variable back to its initial value, just use the clear statement. For basic math, you've got the usual operators, plus or AU. Also div for integer division, mod for the remainder. There are also loads of built-in functions for more complex stuff like ipow for powers. Golden rule. Put your cursor on any ABAP keyword, press F1. The built-in help is excellent. And for cleaner code, use chain statements. If you have multiple data declarations, you can do data, gvvar1 type C, gvvar2 type EI, just use a colon.
Okay, basics covered. What about making decisions? Branching logic, repeating actions. How does AB final control flow?
Standard stuff here, really. For conditional logic, it's I, L on diff. Only one block executes, the first one whose condition is true. You can nest them too. The conditions use logical expressions. EQ equals, NE not equal, LT less than, LE less or equal, GT greater than, GE greater or equal. Initial is very useful for checking default values. Combine them with AND or not. Just remember, AND uses short circuiting. If the first part is false, the second isn't even checked. For testing equality against multiple specific values, case, when, others. End case is often cleaner than lots of else ifs. You can group values with or in a when, but not and or not. For loops, you have D on end while. That repeats forever unless you exit, or you can say do on times. Then there's while.end while. That checks the condition before each loop, so it might not run at all if the condition starts false.
That covers the core logic structures. But what about when things go wrong, or when the program needs info about its own state, like which loop iteration it's on?
Good question. That's where system variables come in. They all start with C. C index tells you the current loop pass, starting from 1. Really useful. But C subrook is probably the most critical one you'll use. It's the return code. If C subrook is 0, the last statement worked fine. Non-zero means an error or specific condition happened. Like after a select statement, C sub arrow means data was found. C subrook equals the 4 means no data found. It checks constantly. For explicit error handling, ABAP methods can trigger exceptions. Like dividing by 0 triggers an exception. If you don't handle it, you get a runtime error crash. So you use try.catch.entry. This lets you gracefully catch specific exceptions listed in the method's raising clause or group them in a catch block.
And finally, for the basics, how does ABA handle text? String manipulation is pretty fundamental.
Yeah, ABAP's got good tools for string processing. You can use string templates inside pipes to build text dynamically. Use curly braces for placeholders. Process and record index. Joining strings uses the and operator. It doesn't add spaces automatically, so you put them in if needed. There's also the older concatenate statement. To break strings apart, use split, telling it the separator character. And for finding or replacing text, the find function gives you the starting position, or -1 if not found, and replace modifies the string. Aki 0 in replace means replace all occurrences. Beyond variables, you also have non-variable data objects. Things like literal static values like 123 or hello that don't change. Constants, declared with constants, give fixed values names, which really helps readability. And for multi-language support, you use text elements. These are texts stored centrally with 3 character IDs so they can be translated easily. You manage them via SAP GUI, even within ADT.
Okay, we've covered the building blocks, variables, logic, strings. Now let's think bigger. Building larger, more organized programs. Why is reuse so important in software development?
Oh, reuse is absolutely fundamental. It brings huge benefits. First, it avoids duplication, less code, smaller programs. Think about having the same complex logic copied in 10 places. Nightmare. Which leads to the second benefit. Easier maintenance. Change it once in the reusable part, and it's fixed everywhere. No hunting down copies. This also massively improves readability. Less repeated code makes programs much easier to understand and debug. It's about building trusted central components instead of just copy-pasting.
So when we use these reusable procedures, what are the guiding principles? How do they communicate without making a mess?
Key principles. When you call the procedure, its code gets loaded. But crucially, neither side can directly access the other's internal data. That's data encapsulation. It's vital for consistency, stops unintended changes. Data exchange happens only through parameters. They define a clear contract, what the procedure needs, importing, what it gives back, exporting, changing, returning. It keeps things clean.
ABP has two main ways for this global reuse, right? What are they, and which one should we focus on for new stuff?
That's right. There are methods, which belong to global classes, and function modules, which belong to function groups. Function modules are everywhere in older SAP code and still essential for many standard functions. But the clear recommendation for any new S/4HANA development is definitely classes and methods. It's the modern object-oriented way. More flexible, more powerful.
Let's focus on classes and methods then, the object-oriented approach. How do we find these global classes and understand their structure?
Finding them in ADT is straightforward Project Explorer, search, Ctrl plus Shift plus A, Ctrl plus H, or just navigating with F3 from code that uses a class. When you open a class, you'll see its sections. Public section, protected section, private section. This defines visibility. Good OOP practice says, make as many components public as necessary, but as few as possible. Keep control, ensure consistency. Inside these sections, you declare things. Types for local types. Data for instance attributes belonging to an object. Class data for static attributes belonging to the class itself. Constants, methods have signatures their contract. Importing parameters. Data coming in can be mandatory optional, method can't change them. Exporting, data going out, always optional. Changing, data comes in, method modifies it. Returning a single result lets the method be used in expressions. Methods also declare exceptions they might raise, class-based errors, or use the older exceptions keyword for Zeiss subject checks.
Okay, we have the class blueprint. How do we actually use it? How does an object come alive?
First, you need a reference variable. Declare it like data gomi object type ref to clami class. Initially, it's empty, just a pointer to nowhere. To create the actual object, you use the new w hotshag operator. So gomi object new w days. New w creates the instance in memory and puts its address in your reference variable. The first time you touch a class, create an instance, call a static method, whatever the system loads its definition and static attributes into memory. You can copy references so multiple variables can point to the same object. Careful though, if you overwrite a reference, you might lose the only link to the old object. But that's okay, because ABA has a garbage collector. It automatically finds and cleans up objects that have no references pointing to them anymore. Prevents memory leaks. A little aha moment. If you want to keep objects around, you can store references to them in an internal table. That way, the garbage collector won't touch them.
That's really useful to know about memory management. So we have our object via the reference. How do we tell it to do things? Call its methods.
To call instance methods acting on the object, use the arrow after the reference variable. Gomi object do something. To call static methods belonging to the class no object needed, use the double arrow after the class name. Utility class format value. The call syntax can vary. Full form uses exporting, importing, changing, but there are shortcuts. If only importing parameters, you can skip exporting. If only one parameter, just pass the value. For exception handling, if it uses class-based exceptions, raising, use try.catch.entry. For older methods using exceptions, you assign numbers, exceptions error 1, and check C subrec after the call. C subrec equals 1 would mean error occurred. And functional methods, those with a returning parameter, are great because you can use their result directly in an expression, like jog result, go my object, calculate value, input 5.
When an object is created, it often needs some initial setup. Is there a special method for that, like a setup routine?
Yes, absolutely. That's what constructors are for. There are two kinds. The instance constructor, always named constructor, it's a public instance method called automatically once whenever you do NDW if tag. Its job is to initialize that specific object's attributes. It can take importing parameters and can raise exceptions if setup fails. If it fails, new W doesn't return an object. Then there's the static constructor, named class constructor. It's a public static method called automatically once when the class is first accessed in any way. First instantiation, first static method call, first static attribute access. It has no parameters because you don't call it directly. It's used for class level setup, like maybe loading some global configuration data needed by all instances.
Okay, but sometimes classes are designed so you can't just create them with NEW. How do we get objects from those restricted classes?
Right. That's where factory methods come into play. You'll see classes defined with create private or maybe abstract classes you can't instantiate directly. Why restrict it? Maybe to ensure only one instance ever exists, a singleton, or to manage instances based on a key, like one object per customer. or maybe to do complex checks during creation. A factory method is usually a static method within the class, whose job is specifically to create and return an instance of that class, or maybe a related class. It controls the creation process, takes any needed parameters, does the work, and hands back the object reference.
So far, mostly single pieces of info. But real apps deal with lists, records, whole data sets. How does ABP manage collections?
Right. For grouping related single fields into one record, ABAP uses structures. Think of it like a row in a table airline code. Flight number, date, all belong together. You declare them, say data gifs flight type B some flight structure. You access components with a hyphen, gifs flight caret. Structures can contain other structures too, nested. You can fill them field by field, or all at once using value, hashtag HeyVH connet 80400. And a really useful trick, the base expression with value. Normally value overwrites the whole structure. With value, hashtag BATHES flight area easels 2024-10224, merges the new date into the existing structure gflight without clearing other fields. Copying between structures, if they're compatible, just use out. If not, but field names match, use the corresponding expression. It copies based on matching names, even if types or order differ. You can combine corresponding and base too. In the debugger, you can expand structures to see all the fields inside.
Okay, so structure is one record. How do we handle a list, a whole table of those records?
For that, ABAP uses internal tables. They're like arrays or lists in other languages, designed to hold multiple records of the same structure. A huge advantage is automatic memory management. The system handles allocating and releasing memory for the table as it grows or shrinks. You don't manage pointers or anything low level. Every internal table has attributes. Its line type, the structure of each row, its access type, standard, sorted, hash standard is default. The others offer performance benefits for specific access patterns, and its key attributes, defining how rows are identified or sorted, primary and secondary keys. Standard tables allow duplicates by default. Hash tables require unique keys. Sorted can be unique or non-unique. You can define table types globally in the ABAP dictionary or locally using types, then data. A common shortcut is just data gfleets type table of some flight structure. That usually defaults to a standard table.
How do we get data into these tables, and then how do we get it back out efficiently?
You often fill them from database select statements or function calls. To add rows one by one, you can fill a structure first, then append it. Using the value HTAG expression is common now. For example, append value, hashtag, caret, AA connet 8123 at tflights. Or to add multiple lines defined in line, get tflights value siege, caret AA. But crucially, if you want to add to a non-empty table without clearing it first, use base, gtflex value, hashtag paste gtflight, caret AUA, reading data back. For single line, table expressions using square brackets are the modern way. Gchange gtflights 5, read line 5 by index, or gflights dtflights, caret LH connet 0400, read by key. Important. If the line doesn't exist, this causes an exception. Suppose you get it line not found. So you need trade get GTH. To just check if a line exists without reading it, use the line exists function. You can even read just one field. LTD flights, line or T-flight splitting date. For processing multiple lines, the classic elevate DT flights into DT flights flight, and a loop is still widely used. You can loop over the whole table, specify an index range from GTO, or filter with where.
What if we need to change or remove data that's already in an internal table?
Modifying entries. You can modify a whole line using a work area by key, modify table G flights from GTO's flight, or by index, modify table GT flights from G flight index 5, or modify a single field directly using a table expression, GT flights caret, LH seats C10N. Inside a loop, if you change the work area, GTO's flight, you update the current table line with modified GT flights from G's flight, deleting entries. Use delete table GT flights where caret D2's way AA, delete by key criteria, or delete GT flights index 5, delete by index. The table automatically adjusts to delete everything in the table. Clear GD flights. This wipes the content and frees memory, but the table variable itself still exists, ready to be sold again.
Okay, this leads us to the big one, interacting with the actual database. How does AB talk to the data, especially with S/4HANA running on HANA?
Right. SAP systems mostly use relational databases, data in tables, rows, columns. Keys identify rows uniquely. Most SAP tables are technically cross-client, meaning one table holds data for multiple business entities. There's a Mandy T field identifying the client. OpenSQL handles this automatically, filtering for your current client, which is really helpful. SQL as pillars. DML, data manipulation. Select, insert, update, delete. These are what ABAP uses in OpenSQL. DDL, data definition. Creating tables mostly done via ABAP dictionary. DCL, data control authorizations handled by ABAP's own system. SAP created OpenSQL as an abstract SQL layer within ABA. Historically, this was vital because SAP supported different databases. OpenSQL provided independence. The database interface translates OpenSQL into the specific native SQL dialect needed. Now here's the thing. Even though S/4HANA only runs on SAP GA, OpenSQL is still the primary way. Why? Architecture, backward compatibility for tons of existing code, plus built-in features like that automatic client handling and table buffering. You can use native SQL via things like ABAP and managed database procedures, AMDPs for super AN-specific optimizations, but usually OpenSQL is preferred.
So OpenSQL is still king, even on HANA, but databases have raw tables, and you mentioned S4HANA adds another layer.
Yes, exactly. That's Core Data Services, CDS views. They are the modern recommended way to access data in S/4HANA. Think of them not as raw tables, but as logical collections of information. They often combine data from multiple underlying tables, applying logic and calculations. S/4HANA uses a whole hierarchy of these views, the virtual data model, VDM. CDS views are crucial because they don't just retrieve data, they also contain annotations, metadata used to automatically generate Fiori UIs or OData services for front ends. Very powerful. In OpenSQL, reading from a database table or a CDS view looks pretty much the same. Both are defined in the ABAP dictionary. Tables via a form editor, CDS views via a source code editor with SQL definitions and annotations.
Let's get into the specifics then. Reading data with OpenSQL's select statement. How does that work, and how do we keep it efficient?
Okay, the select statement, key clauses. From specifies the table or CDS view. Fields, lists of columns you want never use, select all in real code. Always list only what you need. Minimizes data transfer. Where set your conditions. Use ABAP variables here, prefix with @hey, like where carried at GV carrier. Into specifies where the results go, a structure or an internal table. The absolute key to efficiency. Transfer as little data as possible. Be specific in fields, be precise in where. To read just one row, use select single. If nothing's found, C sub C becomes 4. If multiple rows match, it just grabs the first one. For multiple rows, select in a table at GT drawim, gets everything at once into an internal table. Or select into at G, C square and B share tall, and select. This loops, processing results row by row. If your fields list and into target don't match perfectly, names, types, order, use into corresponding fields of at target. It matches by name and converts types if possible. And here's that aha moment with HANA. Code pushdown. HANA is fast, so you push work to it. In your fields clause, you can do calculations. Seats max as free seats. In where, you can use that calculation. Where free seats 10. This calculation happens in HANA before the data even comes back to ABAP. Massively reduces data transfer, huge performance gain, enables real-time analytics that were impossible before.
That code pushdown sounds incredibly powerful. Just briefly, how are new database tables actually created in the dictionary?
You define them in the ABAP dictionary. You set delivery maintenance attributes, like delivery class A, can it be viewed in SC16. Then you define all the fields, including the MNDT client field and your key fields. Then technical settings, things like storage type should be column store on HENA, data class, faster transactional data, size category estimate. Once you activate this definition, the physical table is created in the AG database. A common example used in training is the flight data model tables like SCAR, airlines, SBFLI connections, SF flight, HEA, actual flights. Helps make relational concepts concrete.
So we build these tables. But if complex data is spread across multiple tables, how do we typically bring it together, especially for a user wanting to see it all?
That's where joins come in. In a select, you can use join clauses from table 1, join table 2 on in table 1 field, table 2 field, to combine data from related tables in one go. But writing complex joins repeatedly is tedious and error-prone. And this is exactly why CDS views are so central in S/4HANA. A CDS view encapsulates that join logic, maybe adds calculations or filters. It presents a clean, logical collection to the programmer, hiding the underlying complexity. Much simpler, much more robust.
This talk of reuse and frameworks brings us to a broader point about software design itself. How has the thinking evolved to handle all this complexity we've been discussing?
It's a fascinating evolution, really. Early days, you had what's sometimes called spaghetti programming. Lots of JOTO statements, programs jumping all over the place, almost impossible to maintain. Then came procedural programming, a big step up, using subroutines, function modules, encapsulating code into reusable blocks. Much better structure. But procedural still had a big issue. Generally, all procedures could access all data. This made tracking down data inconsistencies incredibly hard. Which procedure changed this value incorrectly? It was tough to know. That problem really drove the shift to object-oriented programming, OOP. The core idea is simple but profound. Represent real-world things as objects in your code. A flight object, a customer object. Each object has attributes. Its data, like flight number, seats, and methods. Functions that operate on that object, like a book seat method. And the killer advantage, the real aha moment, is data encapsulation. The object's data is managed only by its own methods, no uncontrolled external changes. So that book seat method internally checks availability before changing the seat count. Consistency is built in. Data is protected inside the object.
So the object is the thing, and the class is the description of that thing in code.
Exactly. The class is the blueprint. It defines the attributes and methods all objects of that type will have. An object, or instance, is a specific thing created from that blueprint using UW. You can have many objects of the same class, identical structure, but independent state, different data values. And components inside a class have visibility. Public, accessible anywhere. Private, only accessible inside the class itself. Protected, accessible inside the class and its subclasses. Good design usually means keeping things as private or protected as possible, only making public what's truly needed for the interface. Enforces that encapsulation. You also have static components, class data, class methods. They belong to the class itself, not individual objects. Useful for shared data or utility functions. UML diagrams often underline static components.
One of the most powerful OOP concepts is inheritance. What does that mean for our code? How does it help organize things?
Inheritance models generalization and specialization, and is a relationship, like a truck is a vehicle. A report program is a program. A subclass inheriting from a superclass gets all the superclass's components, except private ones. ABA only allows inheriting from one direct superclass, but you can have chains. Truck inherits vehicle, pickup inherits truck. Subclasses can then add new components specific to them, or they can redefine methods. This means providing a new implementation for an inherited instance method. Same name, same signature, but different logic in the subclass. You can call the original logic using supermethod. Subclass constructors must call the superclass constructor first, superconstructor, to initialize the inherited part. Then they initialize their own specific bits. There's also casting changing reference types. An upcast, assigning a subclass object to a superclass reference go vehicle, go truck, is always safe. A truck is a vehicle. You can only access vehicle methods, but the truck's implementation will run if redefined. A downcast, superclass reference to subclass, go truck, attack, go vehicle, needs the key SD operator and is risky. Not every vehicle is a truck. So you always check first. If go vehicle is instance of cool truck, then you can safely cast. Avoids runtime errors. There are also special class types. Abstract classes can't be instantiated. They define common features for subclasses. Abstract methods have no implementation. Subclasses must provide one. Final classes cannot be inherited from. Final methods cannot be redefined. Useful for locking down core logic or preventing further specialization.
Okay, and finally, there's a concept that seems similar to inheritance but serves a different role. Interfaces.
Right. Interfaces are like contracts. They define a set of methods, attributes, types, constants, but provide no implementation. They can't be instantiated. Why use them? Two main reasons. First, a unified approach for unrelated classes. Classes that don't share an is-a inheritance relationship can still agree to provide the same set of services by implementing the same interface. Ensures common method names and signatures. Second, they offer a simplified view. A complex class might implement several interfaces, each exposing just a subset of its functionality relevant for a particular interaction. All components in an interface are public. A class declares it uses an interface with interface's interface name. It then must implement all the non-optional interface methods using the full name like interface name, method name. And the real power, an interface reference, data loref type bref to if my interface, can hold an object of any class that implements that interface. This gives you polymorphic behavior. You call loref do something, and the specific implementation of whichever class instance loref currently holds will execute. Super flexible code. Casting works similarly to inheritance. Upcast from class to interface is always okay. Downcast from interface to class needs cast and the IS instance of check. Frameworks often return interface references for maximum flexibility.
Wow, what an incredible journey today. From the fundamental shifts with S/4HANA and its development model, right through to the details of object-oriented design in ABA, we've really seen how SAP has evolved its core language.
Absolutely. And while, yes, the technical details can seem dense sometimes, understanding these core concepts, data encapsulation, the power of frameworks, the why behind ABA's evolution, that gives you a really critical lens for looking at any complex software system. And this raises an important question for you, the listener. As software systems keep getting more complex, more integrated, more abstract, how do you think that balance might continue to shift? The balance between these powerful, high-level frameworks and the underlying granular control you get with languages like ABAP. And what does that really mean for the next generation of developers who are learning these tools?
Definitely something to think about. Thank you for joining us on another deep dive. We really hope this has made you well-informed, maybe even a little inspired. And please keep sending in your sources for future deep dives. We love digging into them.